Well, pre-calculus classes, good morning, good afternoon, or good evening. We are going to finish up what we cover out of Chapter 1 with Section 1.8 on inverse functions. I know that you look at inverse functions, I think, a couple of different times in Algebra 2. I know probably the most common place where you look at them is in your exponentials and logarithms unit, but we will review over several things involved with finding inverses and some of the other topics that are involved with them. So if you're finding the inverse function, one of the things you might like to do is, instead of f of x, write it as y, and then an inverse essentially is where you switch x and y. Now, after you switch x and y, you're going to solve for y, and then we're going to rewrite it in function notation if you did switch out the f of x for y. So, like I said, it's kind of, if you want, if you have f of x equals x minus 1 over 5, make it y equals x minus 1 over 5. And then, as I said, your primary step is we switch x and y. So x equals y minus 1 over 5, and now you solve for y. So first thing, multiply the 5 over, so 5x equals y minus 1, and then your last step, add the 1 over, so 5x plus 1 equals. And then the other thing that we do need to do is, if it started out as a function f of x, we do want to go back and use function notation. Now, there is one other small thing that we are also going to include to indicate that it is the inverse function. We use, it kind of looks like a -1 exponent, but basically that is the inverse notation. Where you have certainly seen that in the past is if you think back to geometry. When you worked with sine, cosine, and tangent, you also worked with sine inverse, cosine inverse, tangent inverse when you were finding angle measures, and that'll be something we certainly talk more about as well second semester when we also use some trigonometry for much of the next semester. So anyway, that is finding the inverse of a function. Another one of these, f of x equals the third root of x plus 1. Again, certainly if you want, y equals, now we'll switch x and y. So x equals the third root of y plus 1. Now, to solve for y, first thing we are going to need to do, cube both sides. So x cubed equals, well, the cubed root of y plus 1 cubed is just y plus 1, and then our last step, subtract the 1 over, and then again go back to your function notation and again indicate that it's f inverse of x. So there's just one more example of actually finding a function. A couple of other things here that we'll also look at. Verifying inverse functions. Well, let f and g be two functions such that f of g of x equals x for every x in the domain of g, and g of f of x equals x for every x in the domain of f. Under these conditions, g is the inverse of f. So what that is basically saying is if you plug the inverse of a function into the original function, it will equal x. And if you plug the original function into the inverse, it will also equal x. So that, again, is how you verify that functions actually are inverses. So we'll certainly look at an example of that and verify that f and h are inverse functions algebraically. F of x equals 5 over x minus 2. H of x equals 5 over x plus 2. Well, basically we have to do two things. We have to find f of h of x and h of f of x. So when we plug in first h into f, well, 5 over x plus 2 minus 2. Well, first, these cancel. And so then you're left with, and again, I'm going to make this 5 over 1 over 5 over x. Well, when we multiply by the reciprocal, the 5's cancel, and you are left with x. So that is half of verifying. Now, the other half, you do have to also plug function f into h and show it also equals x. So 5 over x minus 2 plus 2. Again, what I'm going to do here is make that 5 over 1. So then 5 over 1 times x minus 2 over 5 plus 2. Well, again, the 5's cancel, and we are left with x minus 2 plus 2, which is x. Well, if we are going to look at graphing inverses, here we're just going to use the function f of x equals x plus 4, and we're going to come up with a few quick coordinates. Well, plug 1 in, 1, 5, 2, 6, 3, 7, and 4, 8. Well, if you were to graph the inverse, all you do is, kind of like in example 1 where we switch the x and y in the function, all you're going to do to graph is switch the coordinates. So 5, 1, 6, 2, 7, 3, 8, 4. So the domain of f of x is the range of the inverse, and the domain of the inverse is the range of f of x. I know that kind of is wordy. And then graphs are reflections over the line y equals x. So, basically what this is saying is, I'll just do a quick rough sketch here. The line y equals x is the diagonal line there. Well, and so what I'm going to just do real quickly is, since this is a section that does not have, unfortunately, some graphs already in, I'm just going to kind of hand sketch this. So 1, 5, 2, 6, 3, 7, and 4, 8. So here is f of x. Well, if we switch the coordinates 5, 1, 6, 2, 7, 3, and 8, 4, there is our inverse. Well, you can see that these lines are simply reflected over y equals x, which is that diagonal line going through the origin. So that again is what is involved with graphing. Now, one final thing that we're going to talk about is the horizontal line test. I know earlier in the chapter we talked about how do you determine if a function is, or if a graph is a function or a relation. If you have the graph, well, a function passes a vertical line test. A function f has an inverse function. Now, again, this is something going back to geometry, a couple of years ago. If and only if no horizontal line intersects the graph f at more than 1 point. So the question is, does f of x have an inverse function? Well, if f of x is x squared minus 1. Well, again, here's where just talking a little bit about transformations from your parent functions. X squared is a quadratic, minus 1 is going to shift it down 1. And again, just a very rough sketch here. Well, first, f of x is a function. It passes a vertical line test. It does not pass a horizontal line test. So a function does not have an inverse if the original function does not pass the horizontal line test. So, and I don't know if, this is going to be something that may pop up, certainly as you guys look at the homework on Pearson, but a function that passes both vertical line test and a horizontal line test is a 1-to-1 function. So that's something that certainly could come up. I always like to add that in as we finish up Chapter 1. I know some of the other courses I teach that do include this topic there, and so I'm just going to write that in for you guys as well. But we have now finished up Chapter 1.